So plate tectonics, what is it? Remember we talked about the fact that the Earth is broken into tectonic plates. More specifically, the lithosphere, the crust, and the very tip of the mantle make up these tectonic plates. And they're made of two different types of crust. There's oceanic crust and continental crust. Oceanic crust tends to be very dense but thin, causing it to sink. And continental crust is much thicker but less dense, causing it to break. Now these plates we know are in motion. So they're in motion relative to each other. So we're going to look at where they join together. Now what's causing the plates to move? Remember we talked that the heat from the core rises through the mantle and it comes in contact with the lithosphere. When it comes in contact with the lithosphere, it cools off and starts to sink. This movement, where the rise and the fall through the asthenosphere, creates convection currents, and the convection currents create the movement of the tectonic plates. So the oceanic and continental plates sit on top of the asthenosphere, and as the rock in the asthenosphere softens and moves with these convection currents, it drags the plates with it. Now remember, it's going to take them in the same direction that the plate is moving. So if I look at this diagram, this plate is moving down, so this convection current is moving inward. This plate is colliding, so it's also moving towards it. Now when we look at what's happening, we're really looking at what's happening at the plate boundaries. So where the two plates join is a plate boundary. And the plate boundary is where we're going to find most earthquakes and volcanic activity taking place. There are three different kinds of boundaries, and that's what we want to focus on, is what happens at each type of boundary based upon type of crust. So we have divergent, convergent, and transform. So let's look at those. The first one we want to look at is a divergent boundary. So with divergent, we said the plates are dividing, or they're moving apart from each other. Now, what happens at these boundaries is really dependent upon the type of crust. So the first one we want to look at is if I have two oceanic plates dividing. So here's my oceanic crust and my oceanic crust. When that happens, magma rises through the sea floor. It hardens when it hits that cold ocean water and creates what's called a mid-ocean ridge. Now the process that's taking place here is actually called sea floor spreading. We are creating new crust. So this is sea floor spreading, which results in new crust forming at that mid-ocean ridge. The older crust is pushed aside and new crust is in the center. Now we also could have divergent boundaries if it is continental crust. So if I have two continental plates dividing, we get a thinning of that crust, causing it to subside a little, and we get the creation of what is called a rift valley. Now the rift valley could have magma eventually rise through as this thins out even more. So with divergent boundary, the plates are dividing. You could have a mid-ocean ridge through the process of seafloor spreading, or you could have the creation of a rift valley on continental crust. Now with convergent, the type of crust is very, very important. We have two plates colliding, so they're going towards each other. But again, the type of crust really determines the type of landform. So the first one we're going to look at is if I have continental crust. So when my continental plates collide, because it is thick but less dense, it tends to crumple upwards. When that happens, it creates what's called a folded mountain. Now a folded mountain is usually not volcanic because there's no opening really deep enough to allow magma to rise. Now what would happen if I have an oceanic plate colliding with a continental plate? So here's my oceanic plate, and then I have a continental plate also colliding. When this happens, the oceanic plate is more dense, causing it to sink. When it sinks, this process is called subduction. It's pushed below. So when subduction takes place, this plate is destroyed. It's melted back into magma. That magma is going to rise through the surface of the continental plate, creating a volcano. In this case, it's going to create a volcanic mountain because it is on continental crust. Now, in addition to that, because we have subduction where it makes this like V shape, we get a deep ocean trench forming. So a trench can be the deepest part on Earth. So if it's oceanic crust and continental, we get volcanic mountains and a trench. Now, we could also have an oceanic plate colliding with another oceanic plate. When this happens, whichever plate is older tends to be more dense, and that plate will be subducted. So again, we still have that process of subduction taking place. If we have oceanic crust, there's going to be subduction. Now this plate is going to be destroyed again. We're going to create magma. That magma is going to rise through that oceanic plate. It is going to create our volcano, but in this case, it's going to create a volcanic island arc. There's usually more than one that is created. So you get like a curved crescent-shaped chain of them. Now we also are going to have a trench forming because we have subduction taking place, so we get that deep V in there. So if we look at convergent, when the plates collide, if it's continental crust, they push upward to create a folded mountain. If there's any type of oceanic, you're going to get subduction taking place, and you're going to get some sort of volcano formed. If it's continental crust, it forms a volcanic mountain. If it's oceanic crust, it forms a volcanic island arc. If there is subduction, you are going to get a deep ocean trench. Now the last one is actually the easiest when we talk about transform. So transform plates are when two plates slide past each other. Now you notice I have two diagrams here. They could be going in opposite directions, or you could have two plates going the same direction, but one is going slightly faster than the other. Now when they slide, it doesn't really matter what type of crust. The tension builds up between these two, wherever the plates are, that tension builds, until you get to the point where it has to be released, and you get the creation of a fault. And this is where we get very large earthquakes taking place. So the example we always use is the San Andreas Fault. That's located along the boundary between North America and the Pacific Plate. So the San Andreas Fault is created through two plates sliding past each other. So you have three. You have your divergent, divides, convergent, collides, and transform, slides. And those are our three boundaries and the types of landforms created at each.